All right, here we have two engineering students who are about the same size. That means that they have the same mass. Will and Ben. And they're in a weightlifting room. Will lifts 100 pounds of barbell over his head 10 times in 1 minute. Ben lifts the same 100 pounds, barbell over his head 10 times in 10 seconds. Which the student delivers the most power? Let's take a look at this. Let's take a look at the logic first. So what I'm going to do is I'm going to put, since we're going with which student delivers the most power, what we're going to say is the power of Ben over the power of Will. And we're going to put some logic in here, and we're going to say, we're going to call this, let's call this R. And if R is greater than 1, Ben delivered more power. Ben delivered more power. If R is less than 1, Will delivered more power. And if they're equal, if R is equal to 1, that means that the power of Ben is equal to the power of Will. We would say that both delivered the same. Both delivered the same. So how does that look? So first of all, we can go with this, and we know that the power, we can use this general equation, which is the power is equal to the force times the velocity. We can also note that because they're going straight over their head, we can use the force, in this case, would be the weight. Let's call that WE. So we can change this around a little bit, and we can see that the WE times the velocity is power. Now, a couple other things. One thing is to note we don't have velocity, but what we do have is time. So we have the time of both. We have the time of 10 seconds, and we have the time of 1 minute. So let's play around with that. First, we could say that the power is equal to the weight times the distance divided by t. So that's one way to describe it. We know we don't have the distance, but we have a couple of other things to think about. We don't have each individual distance, but what we do have is two engineering are the same size. That means the approximate distance is going to be the same. The weight's going to be the same, but let's take a look at something else. We also said 10 times and 10 times. Although they're the same, let's put this in an equation. We can state that the power is equal to N, that's the number of times, times W, times D divided by T. So remember that N, in this case, is 10, that's the number of times. We have weight, which is W. We have D, which is the distance. And then we have time, which is represented as t. A couple things to note is the only thing that changes is actually this time in this case, but let's proceed. So we can say that the power of Ben over the power of Will. And then what we can say is N of Ben times the weight of Ben times the distance that Ben used divided by the T of Ben, all divided by the N of Will, the W of Will, times the distance of Will divided by the time of Will. So one thing that we know is a couple things we should know. should note now is that the number of times is 10 for both, so that crosses out. We also know the weight's the same at 100 pounds. We also know they're about the same size. So we have this equation. We have R is equal to TW, which is the time of Will, and over the time of Ben. So let's put some numbers in here, and we can say that the time of Will, we look back at our givens, we have the time of Will is 1 minute. So that means that this is 60 seconds over the time of Ben. In this case, Ben time is 10 seconds. So we can put that in for 10 seconds. And we get, and also the seconds cancel out, but the ratio is 6. Now that's it. Basically, now we just kind of think about what that logically says. Well, if we stated up here, if R is greater than 1, Ben delivered more power. If R is less than 1, Will delivered more power. And if R is equal to 1, both delivered the same. But we know that R is equal to 6, so it's greater than 1. That does mean that Ben delivered more power. And that about wraps it up.